my microphone is on its last legs, and so is this topic. Here we're talking about pulleys, right? Where we have two masses, right? Which is 2m and 3m, which are attached to the ends of a light inexpensible string. And they pass through a smooth pulley, right? This means that the tension has changed in direction. That's all it means, is we're just changing the direction of the force. Anyways, write down the equation for the motion of P and Q. Where, okay, this is P and this is Q. Right, wow. For both times, right, the tension would be going like this, right? Yeah, and then here. But because we're on a pulley, right, this changes the direction. So the T is actually going to be here. Alright? And then this will be 2mg, and this will be 3mg, okay? Now, how are we going to work out the acceleration of each mass? Well, first things first is we need to work out an equation of motion. Let's start with P. For P, if we resolve downwards, right? Actually, no. Let's go with Q first. The reason I'm going with Q first is because if we resolve upwards, right? Sorry, downwards. We know that it's going down because this mass is heavier than this mass. Okay? So it has to be going downwards. And we know then that 3mg minus T is equal to 3ma. Okay? And likewise, if we do it for P, we know that it's going upwards. Why? Because this mass is smaller than this mass. And so T minus 2mg is equal to 2ma. And now what we need to do is solve these simultaneously. So let's make T the subject for this equation. T is equal to 2mg plus 2ma. And now all we need to do is make A the subject. So 3m, actually I'm going to do this in blue. 3mg plus 2mg plus 2ma. Oh, sorry, it's in minus. Sorry, this is minus. And this is also minus. Is equal to 3ma. What do you notice about all of these terms? They all have m's in them, so we can cancel out every single m. So now we know that 3g minus 2g minus 2a is equal to 3a. That becomes just g. We'll add 2a on the other side. So g is equal to 5a. And so a is equal to g over 5. Okay? And if you want to put that in your calculator, you can just get it as 1.96 meters per second squared. Okay? Now, find the force exerted on the pulley by the string. Now, first thing we need to do is we need to find the tension. So, the tension is just going to be solving this simultaneous equation. T is equal to 2mg plus 2m 1.96, which is equal to 148 over 25 mg. Okay, we could just leave it as a fraction for this one. Now, what is the force exerted by the string? Well, if you look at the pulley, right, You know that tension is moving downwards on this side, right? Tension is also moving on this side. So therefore, the force exerted is just going to be 148 over 25 mg times 2. Yeah? Which is just going to be 296 over 25 mg. Now, how are we going to find the distance moved from Q in the first 4 seconds, right? Well, what we need to do now is sue that. You get it? So the whole point of this topic is we're linking everything together. We know that S is what we're trying to work out. U is 0. We don't know what V is. We know the acceleration is 1.96. And we know that T is 4 seconds. Okay? We know this one, we know this one, we know this one, and we know this one. So which Suvat equation are we going to use? S equals ut plus a half at squared. S is equal to ut, which is equal to 0, plus a half at squared, right? Which means that S is equal to a half times 1.96 times 4 squared, which is simply going to be equal to 15.968, meters, okay? And the final question, what does it mean if it's smooth, right? It means there are no frictional forces, okay? There's no friction. If this is T, there's no resultant forces going backwards, and likewise on the other side, okay? That's all there is to it. Is this video helpful? Well, make sure you subscribe so you never miss a video like it from me. Well, here's another type of pulley question. Two particles A and B have masses 0.4 and 0.8 respective, connected by a light and extensible string. Particle A lies on a rough horizontal plane, right? And B is over a pulley and hangs freely. We're told that it's 0.5 meters above the ground and a frictional force of 0.08 G opposes motion. So, before we even begin this question, let's draw a diagram. This time, it's going to not look like this, but rather, it's going to look something like this. This is my pulley. And this is the mass that's being held, isn't it? So, what's that? This is A, and this is B. We're told this is 0.4. This is 0.8 G, going downwards. Now, what else do we have? We're told that there's a frictional force, 0.08 G. We're told this is 0.4 G. And then, of course, we have our tension T. And we have our tension T. Is there another force that's exerted? No. Okay, cool. We're also told this is 4.5 meters. And this is 0.5. Perfect. Okay, so how are we going to work out the acceleration? Well, the first thing is we need two motion equations so that we can do this. The first motion equation, let's do it for A, is if we're resolving, is it going to go this way or is it going to go this way? Which one do you think, guys? Exactly, it's going to go down, right? So therefore, we resolve down, we resolve to the left, right? Because remember, it's a pulley. So if it's going there, it's just going to change the direction, okay? T minus 0.08g is equal to 0.4a. Sorry, 0.08g. Why? Because that's the only frictional force. And we know that for B, right, we have to resolve downwards, okay? 0.8g minus t is equal to 0.8a, okay? Now what we need to do is just make t the subject. So, first thing I'm going to do, I'm going to use the top one because it's easier. T is equal to 0.4a plus 0.08g. So now let's put that into our equation. 0.8g minus 0.4a plus 0.08g is equal to 0.8a. A, not G. Jesus. Okay, so now what we're gonna do is put all the A's and all the G's on one side. Sorry, this is a minus. So this will be 0.72g. And if we put that on the other side, that becomes 1.2a, right? And so A is equal to 0.72 over 1.2g. Okay? And if you want to plug that into your calculators, you will get an answer of 5.88 meters per second squared. Okay? Now, here we're told that we're trying to look for the time taken for B to touch the ground. We know that S is 0.5. We know that it's from rest. Ready? The system is released from rest, so it's 0. We don't know what V is. We know that A is 5.88. And we know that T is equal to... We're trying to work that out. So which equation are we going to use? S equals UT plus a half AT squared. Okay? We don't know what that is. Oh, sorry. We know that is 0. So we know that if we make T squared the subject, T squared will be 2S over A. So therefore T is just the square root of that. And so if we plug that into our calculators, what we know, 2 times 0.5 over 5.88, we should get an answer of 0.41 seconds. Okay? Perfect. Now, what's the total distance traveled by A before it first comes to rest? What we will need to do at this point is we need to use 2 Suvat equations. I am running so low on space, but let's see how this works. Firstly, we need to know the final speed. If this is moving 0.5, then this also has to move 0.5. Okay? So therefore, what do we know? We know S equals 0.5. We're trying to work... We know that U is 0. We know V is... Well, that's what we're trying to work out. A is 5.88. And we know T is... 0.41. Okay? So, okay, we can actually use a myriad of different equations. I'm going to use... I think I'm going to use V squared equals U squared plus 2AS. Why? Because these are given, okay? And I don't know... sometimes I'm not sure that my t values will be correct, especially if it's square rooted like this. So usually a good rule of thumb is, in this scenario, pick the option that the question gives you more of the variables. Anyways, v squared will be just 2 times 5.88 times 0.5, which is simply going to be equal to, and if you could plug that in, that would be great. .88 meters per second. Okay? So the square root is just going to be 2.4248. Yeah, you get the idea. So now, to find this total distance, we need a new set of suvat values, where we're trying to work out the distance. We know that the initial velocity is going to be 2.4248. V is going to be equal to 0. We don't know what A is, and we don't know what T is, okay? Don't worry about the fact that we don't know what 3 of them are. We can work out what A is, okay? We can work out what A is because there's no tension on the string during this time. Why? Because it's going to go something like when it's gone to that point and then turn slack again, okay? So, what we're going to do is first we're going to resolve the forces. I'm going to do it here, just in case your eyes are on this side. What are the forces that are happening? Well, we know that 0.08 g, or minus that, it's still going to the left, so this is minus. It's just going to be 0.4 a, and so a is equal to 0.08 over 0.4 g, okay? So that's our acceleration. I'm going to put this in my calculator just to make things a little bit easier to see, because I'm not writing that over there. There's just no space. 1.96, perfect. Or negative, sorry, 1.96. Now we have an acceleration, now we have a v, and now we have a u. So we can use the same equation. A v squared is equal to u squared plus 2as. We're trying to make s the subject. V squared minus u squared over 2a is equal to s, which means that s is equal to 0 minus 2.42. Actually, we know that that's 5.88. We know that because v squared is 5.88. All over 2 times 1.96. And if we plug that into our calculators, we should get an answer of 1.5. And so the total distance traveled is going to be 1.5 plus the 0.5 earlier, which is just going to be 2 meters. And those are your final answers. Thank you guys for watching. I'm going to call it there for today. Join my Discord server if you have any questions, and drop me an email if you want to be tutored and pass your exams. Keep on learning, as you have no idea what you're capable of doing.